expression for resonant frequency omega 0 for the circuit given below. You can see a network here for options A, B, C and D are given. In fact, this is a parallel LC circuit which is also known as Tack circuit because of the fact that it stores energy as magnetic field in the coil and as electric field in the capacitor. Here we are asked to find out resonant frequency of this parallel LC circuit. At resonance, the impedance of a parallel LC circuit is purely resistive. So what we are going to do is we are going to find out the expression of impedance of this parallel LC circuit and equate its imaginary part to 0. Why it is so? As I told you, at resonance, the impedance of this parallel LC circuit is purely resistive, hence its imaginary part will be 0. The impedance of a capacitor C is 1 by j omega z, that of an inductor L is j omega L, and that of a resistor R is R. Hence, the total impedance of this circuit Z can be written as Z is equal to R plus j omega L parallel 1 plus j omega z, that is equal to R plus j omega L into 1 by j omega c divided by R plus j omega L plus 1 by j omega c. By rearranging it, we get R plus j omega L divided by R j omega c plus j square omega square L plus 1, that is equal to R plus j omega L divided by R 1 minus omega square LC plus R j omega c. We are going to multiply the numerator and denominator with complex conjugate of denominator and get R plus j omega L into 1 minus omega square LC plus R j omega L whole divided by 1 minus omega square LC whole square plus R omega z whole square. By rearranging it, we get R minus R omega square LC plus omega square LC minus j into R square omega c minus omega L plus omega cube L square c whole divided by 1 minus omega square LC whole square plus R j omega c whole square. So this is our imaginary part. When we equate that part to 0, we get R square omega c minus omega L plus omega cube L square c whole divided by 1 minus omega square LC whole square plus Rj omega c whole square is equal to 0. This omega get cancelled and we can write R square c minus L plus omega square L square c is equal to 0. From this we can write omega square L square c is equal to L minus R square c, or omega square is equal to 1 pi LC minus R square by L square. From this we can write omega is equal to root of 1 pi LC minus R square by L square, which can be modified as 1 pi root L z. Omega 0 is equal to 1 pi root L z into root of 1 minus r square c divided by L. So our answer is option B. Moving on to next question. The distance between target and radar is reduced to half. Power received is option A, decreased by 16 times. Option B, decreased by 4 times. Option Z, increased by 4 times. Option D, increased by 16 times. It's a detection system that uses radio waves to determine the range, angle or velocity of objects. You can see the basic block diagram of a radar system here. A radar system and a target. Radar system transmits radio frequency energy and it gets reflected from the target. A small portion of reflected energy returns to the radar set. This returned energy is called echo. Radar set uses this echo to determine the direction and distance of the target. The mathematical expression for power received for a radar system PR is equal to PT G sigma AE divided by 4 pi whole square r raised to 4, where PT transmitted power, r distance between target and radar system, that is also known as range. So we can say that the received power is inversely proportional to 1 by r raised to 4. So if we decrease the distance between target and radar by 2, the received power PR will be increased by 16 times. Thus our answer is option 2. Next question. The causal system given by h of z is equal to 6 plus z raised to minus 1 minus z raised to minus 2 is option A, maximum phase, option B, minimum phase, C, mixed phase, and D, none of the above. System is said to be minimum phase when all zeros of its transfer function lie outside the unit circle in Z plane. On the other hand, it is known as minimum phase if all zeros are lying inside the unit circle in Z plane. And it is known as mixed phase if there are zeros outside and inside the unit circle. So what we are going to do is we are going to find out all zeros of transfer function and check whether they are inside or outside the unit circle. Alright. The transfer function h of z is given as 6 plus z raised to minus 1 minus z raised to minus 2, which can be written as 6 plus 1 by z minus 1 by z square. By rearranging it, we get 6z square plus 1 into z minus 1 divided by z square. When we equate numerator to 0, we get 6z square plus z minus 1 is equal to 0. Solving this equation, we get two zeros, z1 as 0.33 and z2 as minus 0.5. From this, it is clear that the zeros are inside the unit circle since mod z1 and mod z2 are less than 1. Hence, we can conclude that it is a minimum phase, that is option B. Moving on to next question. A two-port network is described by the relation V1 is equal to 2I1 plus 3V2, I2 is equal to minus I1 plus 2V2. Then Z parameters of such network is 4 options A, B, C and D are given. In fact, a two-port network is an electrical network model with one pair of input terminals and one pair of output terminals. It is commonly used to model the voltage and current characteristics of complex electrical networks. Relation between input and output signals of a two-port network are described by different parameters such as impedance parameters, admittance parameters, H parameter, etc. From this equation, it is clear that they are H parameter. Here V1 and I2 are expressed in terms of I1 and V2. So this is the H parameter equation. V1 is equal to H11 I1 plus H12 V2, I2 H21 I1 plus H22 V2. By comparing this equation with that given in question, we get values of H parameters as H11 is equal to 2, H12 is equal to 3, H21 is equal to -1 and H22 is equal to 2. In the question we are asked to find out set parameters of that network. This is the set parameter equations to represent a two-port network, and for converting the H parameter to set parameter, this is how they are related, how H parameter and set parameters are related. By substituting the values of H11, H12, H21 and H22, we get Z11 as 3.5, Z12 as 1.5, Z21 as 0.5 and Z22 as 0.5. Thus our answer is option D. Correct? All enjoyed it. Thanks for watching. Thank you.